All right, now the first question we're dealing with is a domain question. Now when you're dealing with a domain question, the first thing you need to ask yourself are, what are the rules of the domain? Rule number 1, no dividing by 0. Rule number 2, no square roots of negative numbers. And rule number 3, no ln of negative numbers or ln of 0. So whenever you're doing these domain problems, you should always be going through these three rules in your head. Ask yourself, do I see a fraction bar, by which I might possibly divide by 0? Do I see a square root, by which I might take the square root of a negative number? Do I see any logs or natural logs? And if I do, I need to worry about that. So looking at this first problem, I see 2 squared of x plus 2 divided by x squared minus 3x minus 4. So going through these rules, do I see a fraction bar? Yeah, I do. I see a fraction bar. So I need to make sure I don't divide by 0. How can I figure out where I might divide by 0? I need to ask myself, when is this guy equal to 0? So I'm going to go ahead and factor that. That factors as x minus 4 times x plus 1. And that equals 0 for x equals 4 or x equals negative 1. So those are going to be excluded from my domain because if I include them, I end up dividing by 0. So that's not allowed. So we're done with rule number 1. We've made sure that we don't end up dividing by 0. But we do need to look at rule number 2, which says no square roots of negative numbers. See, we have a square root here. So we have to make sure that the inside of this is not 0, or rather, not less than 0. So we're going to say the x plus 2, let's get a different color here. We're going to say the x plus 2, that's sitting underneath the radical. We want to ensure that that is larger than or equal to 0. Okay, well that just means I need to subtract 2 from both sides. And that gives me x is larger than or equal to negative 2. I don't know if the green shows up very well, kind of faintly, but I'll stop using the green. Anyway, we have now x is larger than or equal to negative 2. So we're going to include that as part of our domain. Anything that is less than negative 2 will cause this inside of this radical to be negative, which is not allowed. So let's look at a number line. I think the best way to kind of get our hand on what we're looking at here as far as what our domain is to draw a number line. So we know 4 is going to be excluded. As a result, I'm going to draw an open circle around that. I know at negative 1, that's also going to be excluded by virtue of x equal negative 1. Negative 1 is going to be removed. And then we have x equals negative 2. It's going to be allowed. Notice we have x is greater than or equal to negative 2. So I'm going to put negative 2 over here with a filled in circle. And then because x is allowed to be greater than or equal to negative 2, I'm going to shade it toward the right, making sure to hop over those open circles. So my domain consists of these 3 intervals, here, here, and here. Now I need to ask myself, how do I describe this interval in interval notation? Well, I want to take this interval from negative 2 to negative 1, so I'll write negative 2, comma, negative 1. Because I'm allowed to include the negative 2, because it's got a closed circle on it, I'm going to put a bracket on the negative 2. But because I'm not allowed to include the negative 1, I'm going to put a parentheses on it. Okay? Cool? I want to include everything from negative 2, including negative 2, but not all the way up to negative 1, but not including negative 1. Okay. Now I'm going to join that with this interval, the interval that goes from negative 1 to 4. Notice I'm putting parentheses on both negative 1 and 4 because I don't want to include either negative 1 or 4 because they're excluded. They have open circles around them. And lastly, we have the interval from 4 to infinity. It goes on forever. So we're going to say 4 with an open parentheses, again because we're not including it, to infinity. Now, we never include infinity. Infinity always gets a parentheses put on it, but that's just a rule that you need to know. So anytime you never include infinity. If you ever see a bracket on an infinity, that's just improper notation. Okay, so that wraps up this first problem. Let's jump into the next. Next question asks us to find the domain of ln of x minus 2 minus x. So again, we're going to run through that checklist of rules. Rule number 1, don't divide by 0. Well, I don't see any fraction bars, so I don't have to worry about that. Rule number 2, I need to not take the square root of a negative number. So do I see any square roots? No, I don't worry about that either. But do I see any natural logs or logs? Yeah, I do. So that means rule number 3 needs to come into play. Remember, rule number 3 says no ln of negative numbers or ln of 0. You're not allowed to do either of those, okay? So what we're going to do is we're going to check each argument of each ln and make sure that it's strictly larger than 0. So I'm going to say this x here, it needs to be larger than 0. And this 2 minus x, this guy here, it needs to be larger than 0 as well. We're going to solve each of these separately. Actually, this one's pretty much already solved for us. X is larger than 0. So I'm going to draw a number line. Here's 0. Notice it says x is larger than 0, strictly larger than 0. It's not x is greater than or equal to 0, it's strictly larger than 0. So I'm going to put an open circle on 0. I haven't really solved this one yet, so I'm going to go ahead and do that. You can subtract 2 from both sides, and that means you get negative x is greater than negative 2, and then you can multiply or divide both sides by negative 1. Now, a rule of inequality is that, remember, anytime you multiply through or divide through by a negative, you have to flip the inequality. So instead of saying negative x is greater than negative 2, we're now going to say x is less than 2. Okay? So x is less than 2 tells us we need to mark down 2 on our number line, put an open circle around that. Now, remember, x is greater than 0 means we shade to the right. We would keep going beyond x is equal to 2, but remember, x is supposed to be less than 2. All right, so now we're going to look at x equals 2 and shade, because it says x is less than 0, shade to the left. Well, we've already got this shaded, but let's just shade it again for good measure. And we would love to keep going beyond x equals 0, but remember, x has to be larger than 0. So we can't include either of these, because, and think about it this way, if I were to include either of these, any points from either of these, it would make one of these two arguments negative. Sure enough, pick your favorite number from this side, let's say negative 1. Sure, I can safely plug negative 1 in here, 2 minus negative 1 is positive 3, but I can't plug in negative 1 there, that causes issues. I get ln of negative 1, which is not allowed. What about something larger than 2? How about x equals 3? If I choose x equals 3, I can plug that in here safely, ln of 3 is fine, but 2 minus 3 is negative 1, which wouldn't be allowed. So our interval is just from 0 to 2, not including either 0 or 2. So we're going to put open parentheses on either side of that. Cool? All right, next problem. Okay, so here we're dealing with finding the domain of the square root of 9x minus x cubed. Remember, we want to go through the checklist of rules. Rule number 1, you can't divide by 0, so I'm going to look for a fraction bar. And I'll see a fraction bar. I'm going to skip rule number 2 for a second and go straight to rule number 3, which says I need to worry about any logs or natural logs. Well, I don't see any in here, so I don't have to worry about that. Let's go back to rule number 2, though. Rule number 2 says you can't take the square root or any even root of a negative number. Well, here we have a square root. It's an even root. It's the second root. We have a square root of 9x minus x cubed. So we want to make sure we don't divide by, or not divide, but take the square root of that negative number, and we're going to do that by just factoring the inside. We want to make sure that 9x minus x cubed is greater than or equal to 0. Remember, it's allowed to be equal to 0 because the square root of 0 is 0. That's perfectly fine. You can see that. Okay. So now what? How do I solve this? How do I determine the values of x that cause this to be true? Well, here's what we're going to do. We're going to factor that. Notice that 9x and x cubed both contain an x, so I'm going to factor that out. Then we'll be left with 9 minus x squared is larger than or equal to 0. And we can continue to factor here. 9 minus x squared can factor as, if you know as a difference of squares, 3 minus x times 3 plus x. Okay, so now we have 3 factors here. X, 3 minus x, and 3 plus x, and nothing more can factor. But now that I've gotten all this, I can now use what's called a number line or a sign chart, or whatever you want to call it, to go ahead and figure out what parts of my interval am I going to include. So draw my number line. X equals 0 causes that to be 0. X equals 3 causes this term to be 0. And x equals negative 3 causes that, or this term to be 0. So we have 0, 3, and negative 3. I'm going to mark those down on my number line. All right. And now at this point, we're going to pick our favorite number on each of these subintervals and test to see whether we get a positive or a negative. The reason we do this is because when you test a number from a subinterval like this, whatever that sign is, whatever the behavior you get out from plugging that into a function, will be representative of every point you plug in from that interval. So for instance, I'm going to pick my favorite number larger than 3. That might just be 4. If I take 4 and plug it in here, let's plug it in up into this expression. 4 times 3 minus 4 times 3 plus 4. Now what sign is that going to give me? 4 is positive, 3 minus 4 is negative, 3 plus 4 is positive. So we have a positive times a negative times a positive. Well, we said a negative one time, so that means we're going to have a negative. So we're going to put a negative over the interval we selected 4 from. We selected 4 from this interval, so we're going to put a negative over it. Okay? Let's continue this process. Pick your favorite number, for those of you watching at home. Pick your favorite number between 0 and 3. Some of you said 1, some of you said 2. Let's go with 1. One's a little bit easier to plug in. So when I plug in 1 for x here, I get 1 times 3 minus 1 times 3 plus 1. Well, ask yourself, does it come out to be a positive result or a negative result? Positive, 3 minus 1 is positive, 3 plus 1 is positive, positive times a positive times a positive is a positive. All right? Now remember, I'm putting a positive over the interval from 0 to 3 because we selected 1 from this number line, or from this interval. We're going to repeat this process. Keep picking your favorite number between each subinterval. So this interval here, negative 3 to 0, I'm going to pick negative 1. When I plug it in, I get negative 3 minus negative 1, so 3 plus 1. And then we have 3 minus 1. Negative, positive, negative. Oh wait, negative, positive, positive, I should say. Negative, positive, positive gives me a negative result. And as you can imagine, I'm going to repeat this process one more time. Let's use an eraser instead of my hands like a savage. If I pick, say, negative 4 and plug that in over here, I'm going to get negative, positive, negative, but a negative times a negative makes a positive. So, now, how do I decipher this and make a domain? Well, we can see that we want this to be positive. In fact, for those of you watching, you might, instead of saying plus, you might want to say like a check mark for these. And you might want to say an X for these. Instead of labeling plus or minus, you might want to label check or X, because when you ask yourself, does it satisfy the criteria? Positive does, because we want that. We want it to be a positive number. So checks and X's work better than pluses or minuses, because you might think, oh, plus is good, so I should always include plus. Well, there might be instances where you want the negative. So a negative is going to be preferred, and so you actually want these guys as opposed to these guys. So make sure you're paying attention to the condition here. The condition here is greater than or equal to 0, and those are these intervals here. Okay, so that means I want this interval and this interval. Now the question is, do I include these endpoints, negative 3, 0, and 3? Well, of course I do, because if I plug in negative 3, 0, and 3 into the original, or into any one of these factors, I get 0. Is that okay? Yeah, of course it's okay. I have greater than or equal to 0 here. So that means I'm allowed to plug in the values that cause it to be 0, namely negative 3, 0, and 3. Are included. So I'm going to put closed circles on those points. And now we have a giant number line. Let's go ahead and make our interval. This interval goes from negative 3 all the way down that way toward negative infinity. So this goes from negative infinity up to 3, or negative 3 I should say. We're going to exclude infinity because we always exclude infinity. We never include infinity. And we're going to include the negative 3 because it has a closed circle on it. Now we're going to join that with the interval from 0 to 3. So we'll put 0 to 3. But again, we're going to include 0 and 3. We're going to put brackets on those numbers because we want to include those in our domain. They are allowed to be plugged into our domain. So this is our domain. Next question. Okay, so this problem is actually really common. You're going to see this a lot in this course. It's good that we hammer this down now. So this is some piece of paper. What we're going to do is we're going to cut some corners from it, square corners with side length x. And then what's going to be left is this shape. Once we cut those corners out, we're going to be left with this shape, which now has these as flaps that would fold up to make a box. So here's x, this is x. We'll say this side length was the 17 and this side length is the 11. The question wants us to find the volume of such a box. If we were to actually make this, we would grab an not 8.5 by 11, but an 11 by 17 sheet of paper, cut those pieces out, and then fold up the flaps. What would the volume of such a box be? Well, let's figure out what the dimensions of such a box would be. We know that volume equals length times width times height, but what are the length, width, and height of such a box? Well, realize that when I take this flap here and fold it up, this dimension here, when it gets folded up, becomes a height. Think of it as actually sticking out from the board I'm writing on. When I fold this flap up, this flap will be pointing out at us, and its height will be x. So hopefully that makes a little bit of sense. But the other dimensions are not just going to be 17, 11. That would be too easy. Remember, 17 would be the full length, but if you recall, we cut out squares from these corners. So really, we're dealing with 17 minus 2x. We're dealing with the full length of 17. But then we said, you know what? We're going to take an x out of this chunk, and we're going to take an x out of this chunk. So what are we left with? What we're left with must be the full length, but then minus the 2x. The x that we cut out over here, and the x we cut out over here, giving us 17 minus 2x left over. So let's just say that is our length. Conversely, or not conversely, but likewise, we're going to have this side length was 11 but we're going to once again realize we're cutting out an x here and an x here, so minus 2x. That's going to be our width. So that is our width. And as I said before, the height is, and again, you might not be totally convinced of this, and I apologize if I can't convey it. Actually, here's what I can do. A piece of paper lying around, so I'm just going to cut it up, or like make such a flap. Okay, so tried, but here's this. I had what was a rectangular sheet of paper, and I cut out these corners, and now I can fold what's left, what's sticking out as a flap. Okay, so now I have kind of a flap shape, kind of a box getting ready to be made. The height of this flap, or the height that this is sticking out, is exactly the amount that I cut out from the sides. That's why the height is x. Okay, we're done with that. Okay, so we've got, as I said before, the height is just x. So we've got a function length times width times height, but now it's going to be all in terms of, let me make some room for myself, all in terms of x. Let's switch to red. V equals, we know the length is 17 minus 2x. The width is 11 minus 2x. Gotta make sure I'm not going off camera here. Okay, I'm not. Good. Now, that's the function. Great, we're done with the first part. But the next part is, what is the domain of this guy? Well, remember the rules of the domain are 1, can't divide by 0. I don't see any fraction bars, so I'm pretty happy. Rule number 2 is I can't take the square root of a negative number. Well, I don't see any square roots either, so I'm pretty happy about that. And then I ask myself, do I see any logs or natural logs? No, I don't see any of those, so I feel like I'm in the clear, right? No matter what value of x I plug into this, I should be fine. That's true if this was just a function standing by itself. But remember, there was an associated application with this. We're talking about a box where we cut out a side length x, right? So we have to think that fourth optional domain rule, which says that in a real world problem, you have to make sure things make sense. So can I cut out a negative side length? Can I cut out a square that measures negative 2 inches on its side? No, it doesn't make any sense. Like, no one says, hey, I need about negative 10 feet of plywood. No one says that. It doesn't make any sense. So x is certainly going to have to be positive. So that makes sense. And many of you might have actually gotten that far and said, okay, now I'm done, right? Close. The only other problem is that, sure, x must be positive, but if x is too positive, if x is too large, we end up cutting out too much. We end up, if we say x was, say, more than 17, or not, let's say more than 10, we're cutting out a chunk that is this large from the side of the paper, and then we're cutting out the same chunks everywhere. Well, if we cut out that much from the paper's just gone. We can't cut out that much without causing the paper to evaporate. You can't cut out that much. That's too much to cut out. There won't be any flaps left over because we've basically removed the entire side of the paper. So we need to make sure that we're not making x too large, that one of those dimensions becomes negative. This guy, 17 minus 2x must remain positive. So that means, I'll solve it really quickly for you. That tells us that x must be larger than or equal to 8.5. Okay, sorry, not larger than, but less than or equal to 8.5. If it's any larger, if x is any larger than 8.5, oh, that's still on the screen. Okay, cool. If x is any larger than 8.5, then we've cut out a square so large that this side completely disappears and we can't have that. All right, what about this side? This is the width. We take 11 minus 2x and set that larger than or equal to 0. That gives us x is less than or equal to 5.5. If x is anything larger than 5.5, the entire side, short side, is destroyed. So we have x needs to be less than 5.5 and less than 8.5. Well, I think we can agree that if it's less than 5.5, it's certainly going to be less than 8.5. So we'll draw a number line. We know x has to be larger than 0. And x certainly can't be larger than 5.5. 8.5 is down here. Sure, we'll write it down. But notice we're not really going to, it's not going to get involved because we know that x can't be any larger than 5.5 to begin with. So this piece won't matter. Our domain will just be everything from here to here, 0 to 5.5. Now, a good question would be, do I include, I know I actually put closed circles in for them. The question is, do I include them or not? It's always a tough question. If I were to include 0 in 5.5, it means the volume is 0. It means we have no box, right? It means that, in fact, if x is 0, it means I didn't cut anything out. I took the flat sheet of paper, didn't cut anything out, and then I just have a piece of paper. Well, the volume of a piece of paper is 0. So, and that makes sense because if I plug in 0 there, I get 0. But does that make any sense to do? We're not really making a box, so should we include it? Maybe not, but at least it's not making our volume negative, right? We can't have a negative volume, which is what I think we're trying to avoid. X equals 0 allows this to be 0, which is fine. It's not a negative volume, so we're pretty happy with that. What about 5.5? In a similar case, if I plug 5.5 in for 11 minus 2x, I get 0, which is weird. Having a 0 volume is weird, but it's okay. Now, the next question we're going to go ahead and do right now. All right, this next problem asks us to find the domain and the range, so it's a double whammy here. We need to find both pieces here. There's 2 ways you can do this, and I recommend doing it the second way, but I'm going to show you the first slower way first. So we have 25 minus x squared. We remember rule number 2 of the domain says you can't take the square root of a negative number, and because we see a square root, we need to make sure that doesn't happen. So we're going to say 25 minus x squared is greater than or equal to 0, and we're going to solve that. This can factor into 5 minus x times 5 plus x. The values of x that cause this to be 0 are 5 and negative 5. So I want to mark those down on a number line. Remember, I can include 5 and negative 5 because they cause my domain to be 0, or they cause the inside of the square root to be 0, which is okay. So we're going to include these. Then we're going to ask ourselves, do we shade in the middle or do we shade outward? Well, you can test intervals or test points. We're going to pick our favorite number larger than 5, like 6. 5 minus 6 is negative, 5 plus 6 is positive. A negative times a positive is a negative, which is wrong. We cannot have that, so we're going to put an X over this interval where we chose the 6. That can't work. Pick your favorite number between negative 5 and 5. What's everyone's favorite number between a negative and a positive? 0. And in fact, 0 is pretty easy to plug back here into the original. If I plug in 0, 0 squared is 0, 25 minus 0 is 25, the square root of 25 is 5. It's allowed, so we're good. We're pretty happy with that. We picked 0 on this interval, it worked, so we're going to put a check over that interval. And if you pick your favorite number less than negative 5, like negative 6, plug that in here, you get a positive times a negative, which will be a negative, which is not allowed. So this is the interval we're looking for from negative 5 to 5. Let's make this a bit larger. Negative 5 to 5. And we're going to include both of these, remember, because we put closed circles on each of those. And because if I were to plug them in, I don't have a problem. Square root of 0 is 0, that's all right. So that was the first way to do this problem, but let's talk about a different way. In fact, this is also, this method doesn't quite give us the range, which would be easier doing the second method that I'm about to show you. You should recognize this graph here as one of those special graphs that I told you about. Square root of 25 minus x squared is a semicircle. And it's a semicircle because this is a 25, it's a semicircle of radius 5. So that means from the center out to the edge, that's a distance of 5. From here out to this edge, that's a distance of 5. So we can see that the only values of x that can be plugged in are those between negative 5 and 5. In fact, the function only exists for those values. No value of x beyond x equals 5 or beyond x equals negative 5 gives us something on the function. The function exists solely between, let's kind of highlight that with blue. The function exists solely between negative 5 and 5. That was the domain we established earlier. The domain is negative 5 to 5. The function does not exist anywhere outside of that range, or that domain, I should say. Now, what about the range? The range is a bit easier to see now, given that we've drawn it. We merely ask ourselves, what is the highest value of y that we see? Well, we know this peak value, because this is the origin, 0, 0, and this is 5 up. This is the coordinate 0, 5. So it seems as though the largest value that this function takes on is 5, because it goes no higher than 5. The lowest value this takes on is, well, I don't think this function goes any lower than y equals 0 here. It doesn't go any, you see nothing below the x-axis. So as a result, we know the lowest value, 0. So when you're asking yourself, how do I find the range? It might help to see what the graph of that function looks like. You then ask yourself, what's the highest value? In the words of Ludicrous, how low can you go? Right? How low can you go on this function before you hit rock bottom, or before you hit? And that's probably what you're asking yourself when you're taking this class. How low can you go before you hit rock bottom in this class? We have 0, y equals 0 as our lowest value, so that means the lowest value on our range is 0.